What education? Yeah, so it's just, I usually use midterm exam in the, it's the same meaning, but if you want exam, then maybe you can use exam. Okay, so exam one. Yeah, because yeah, there are no traditional finals in here, so maybe your choice of word is more right. Oh, thank you, Morgan. Yeah, my house is okay. So some of you may know, but my house was got lightning, so my Wi-Fi is just shut off. Everything is okay, but now it is get back to where. So thank you for worrying me. Mhm. So maybe I think that you guys that all get the feedbacks from the your last quiz, right? So if you don't get it, then please let me know. And we will have 3 more video quizzes in this semester. Pardon? Uh, pardon? Yes. So bonus points will be given for dropping the lowest score, refreshing the lowest score as the pre-credit. So guess, I will just memorize everything, everyone who did the 2 videos. So this policy is still used for next video quizzes. So yeah, so in honestly, if you just do the video quiz twice, then you can get replace your lowest grade on the quiz as your pre-credit one, right? So in this course, yeah, I think that except the exam days, and we have 8 traditional quizzes using the WebAssign and 4 video quizzes using the eCampus, right? So does it answer your question? Great, thank you. Okay, howdy. Okay, great. So let's start with some announcements. So as I stated in this, lecture note, that exam 1 will be held in the next week. So it will be held in the online via Zoom. So you need to be not this classroom, but you need to be some other places. You can get some Wi-Fi, and also you can get some second device proctoring. So yeah, so I will give you more detailed instruction at this Thursday. And this exam covers chapter 1 to chapter 3. And I already sent some email about how many numbers are actually, there are 4 types of the exam programs. So first one is just filling a blank. And the second one is kind of short answer or essays. And third part is multiple choices. And the last one is just, drawing some your answers in the paper and just taking picture on your answers. So these are 4 different types, and the points will be almost the same. But yeah, each of the part will have 23 to 27, I think, but I'm not sure right now, so I need to see that. But yeah, points should be almost same, right? And also the portion of each chapter is also almost same. So I think that chapter 3 is much more smaller than other 2 chapters because we only use 2 days to lecture in chapter 3. And the Madeline asks that what day of the week is the exam, and as Destiny says, it's Tuesday. So next Tuesday we will have an exam. So that's why I say it is next week. Okay, do you have any question on exam 1? Great. Then next one is about the test. So what I mean test is just I uploaded in the tomorrow, as I said in the email, to serve the first type of question by taking picture. You need to learn how to upload the multiple photos into a single file, a single PDF file. And I will give you some instruction on the email. So if you just go there and quizzes, then you can see this sandbox upload your PDF. And by clicking continue, there was some question. So in the exam time, you will also see such a question with different ones. But so by clicking browse my computer, you can just upload some files and save and submit to submit the files, right? And for making a PDF, making multiple photos into a PDF is different for each devices. But yeah, if you use the Android, then you need to download some apps. So you need to, there are plenty of ways to do it in Android. And if you use iPhone, then there are some, without any downloading any apps, you can do it using your share button and using iCloud Drive. So I think, yeah, I hope that you are getting overcome such difficulties. But if you do not know how to do it, then please let me know so that I can figure out how can we do such making multiple photos into a PDF file. Okay, that's the second announcement. Okay, do you have any question on this? So please do it until the Thursday. Then I will give you 5 extra credit, 5 points on your quiz at this week. So it means that if you got the quiz 0 on this Thursday's one, but if you just uploaded this test, then I will give you 5 credit, 5 points on the quiz, right? So. Pardon? Yes. So the question from the classroom is that can you take the exam early? So and the answer is yes, but it is actually no. Sorry, actually, yeah, we need proctoring, right? So it means that it starts at the 1:30 p.m. and end at the 2:45 p.m. and you need to take your exam at the 1:30 p.m. early, as usual in the classroom, as usual in the class time, right? Okay. Does it answer your question? Great, thank you. Okay, and the next one is, yes, the third one is quiz. And yeah, as usual, we will have a quiz on Thursday. So it will be uploaded on WebAssign. So you can serve your quiz from 2:45 p.m., the end of the class, and the end of the day, right? From the 2:45 to the end of the day. So that's about the quiz. And from Linji's request, I will make a review material. So review material is nothing but some kind of problems which is similar to the exam problems, right? So by solving review material and seeing some solution, maybe you can get some, some kind of atmosphere or some kind of knowledge that what kind of programs going on exams. So I hope that you can solve all problems in review material, then you can get a good score on the exam one, right? So it will be also uploaded on Thursday. So these are all announcement. Do you have any other question on exams or quiz or anything else? Okay, great. Then let's deal with chapter 3. So before going chapter 3, what we run in the last time is the order requirement graph, right? Just briefly review last time. In 2.5, we learned order requirement diagram. So it looks like, for example, yeah. So it has some name, T1, T2, T3, and it may have some arrows or not. Yeah. And we notice that the number inside of this circle means the time you need to complete the task, right? For example, the task 1 takes 3 minutes to complete the task, and task 2 takes 7 minutes to complete the task. And also these arrows means dependency. So what I mean dependency is that you cannot do task 2 until you finish task 1 and task 3, right? Because they are needed as a prepared job. And if you can do task 2 only when you finish task 1 and task 3 already, right? So this arrows means dependency. And this kind of task 4, like there are no arrows in the task, then we say that this is the independent task, right? So if your task has no dependency, then we say that this is independent task. So now in this chapter 3, we will learn how to schedule those tasks so that we can decrease the cost or decrease the amount of time we need to use to complete all the jobs. Yeah, so that we can get the optimal scheduling for companies, right? Okay. So first thing we run in this scheduling task is about the processor. So a processor is a personal robot or personal machine or robot, anything that works on the task, right? And machine scheduling program is to schedule tasks such that the cost needed for completing task is minimized, right? So usually we deal with the cost as your time, right? Because if we just do the same amount of task in the smallest time, then it'll be much more better than doing in the longer time, right? So in order to serve such a program, we just assume some kind of, that these tasks are kind of, there are some assumptions we need to use to optimize this. So first assumption is that every task can be represented as order requirement weighted graph. So we already deal with when the tasks are converted as your order requirement graph. And also we will adopt a priority list on the task, right? The priority list is that, so for example, maybe in this graph, you can set, it is just some list of tasks, right? So for example, you can just think that T4 is much more important than T1 and T2, T3 as a priority list. So it is any of the list of the tasks, right? But if you have such a priority list, then when you're ready to start to complete the task, then first of all, you need to choose the T4 as the first one because it is the most important task. And after getting T4, then you can do T1. And after getting T1, you can do T2 and so on, right? So this kind of list, which says that which one is the most important and which one is the less important, is called priority list. And we will have some priority list, or we will make some priority list if it doesn't given in the problem, right? And the next one is that no processor stays idle if there is a task to be done. So it means that, so for example, if there are 3 processors and one is working on T1, right? But in that time, other 2 processors do not work on anything. But it's absurd, right? Because it is not definitely efficient for completing tasks. So we always assume that if there are tasks to be done, then every processor should work at this time, right? So that's the third assumption. And if a processor starts working on a task, then the work will continue until the completing task, right? So for example, it means that, T1 takes 3 minutes, right? So maybe someone assumed that, okay, then I will do 1.5 minutes and you can do the last 1.5 minutes, but it doesn't allow it in this diagram, right? Because it makes it a little bit more complicated. Also, in that case, you can just divide your task 1 as first part and last part so that you can make another order graph, right? Order requirement diagram, right? So we always assume that if you just process the status on the task, then it will take full time in the task to complete it, right? So it doesn't divide the task or anything else. And the last assumption, that it is already for this class, but this cost on the task or time of the task assumed to be minutes. Yeah, so every task time, so for example, this 3, it means 3 minutes, and this 7 means 7 minutes, and so on, right? So these are our assumptions on this scheduling task, right? Okay. Do you have any question on this? Good. So based on this assumption, okay, so our goal is to minimize the completion time for given number of processors, and tasks is considered ready if all its predecessors in the diagram have been completed, right? So for example, in this diagram, at the first, T1 is ready, right? Because you can just do T1. And T3 is ready because there are nothing you need to do to task T3. And T4 is also ready at the first because T4 is just independent task. But T2 is not ready, right? Because T2 is not ready unless T1, T3 are completed, right? Because by dependency of this task, T2 only can be done when T1 and T3 are completed. So at the first point, or at the initial time, yeah, T2 cannot be ready, right? So this is what the examples of task is ready or not, right? Do you have any question on this? Okay. Great. And there are first algorithm we will learn is called list processing algorithm. So assignment of this processor is that the lowest numbered idle processor is assigned to the highest priority ready task, right? So let's see, we did some examples. So suppose that there are processor 1 and processor 2, and this is the starting point. Then the lowest number processor is P1, right? So, and we just use this priority list at first. So we just take T4, assign T4 to P1 because T4 is the most important one. And P1 is the lowest number processor, right? So this T4 takes 9 minutes, right? So say 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So T4 takes 9 minutes, but now P2 is idle, right? So instead of making idle, then next, since P2 is idle, so we can just assign the next important task, T1, into P2, right? So here T1 is 3 minutes. So after 3 minutes, it's done, right? So here is done T1, and here is and P1 is T4 is done after 9 minutes, and T1 is done after 3 minutes. Then again, you can assign T2 in the P2, but it is not impossible, right? Because T2 depends on T1 and T3, but T3 is not completed, right? So in that case, our algorithm says that if there are ready tasks, then repeat step 1, which means that by number A, we can assign T1 into P2. But if there are no ready tasks, but not every task is completed, then idle process remains here idle, right? So here we have some ready task, right? But, sorry, here, not T3, here T3 is ready to task, right? So, but even if T3 is not important than T2, but still we can do T3 at this point. So assign T3 in here because it is ready task. And T3 takes 8 minutes. 1, 2, 3, 4, 5, 6, 7, 8. So here is the ending point of T3. And at the after this 9 minutes, you know that T4 is done and T1 is done. T3 is still working on, so there are only left thing is T2, right? But you cannot start T2 until T3 is ready, right? So at this point, it is idle, means that do nothing, right? So these are idle point. And after completing T3, then there are two processor remain, and now we can do T2 using 7 minutes. 1, 2, 3. 1, 2, 3. So, and the second one remains idle, right? So this is the least processing algorithm. So first of all, just assign the most priority one into the first processor and assign the second most priority one into the second processor and so on. And after some of the processor complete the job, then assign the task which can be ready, right? If there is no task ready, then just wait. But after getting some ready task, then just assign it again, right? So it's a little bit simple. Okay, do you have any question on least processing algorithm? Could you speak a little bit more? Idle tasks come up in the process between processors, right? So could you repeat your question again? Sorry. So I thought you can only have them split and not. Yeah, not in between that. Yes, you're right. Here, okay. So what I mean is that actually, for example, to complete to T2, yeah, we need to complete T1 and T3, right? But here, at this point, so 1, 2, 3, 5, 4, 5, 6, 7, 8, 9. So after the 9 minutes, we still didn't complete T3, right? But we already completed T4 in the 9 minutes. So that's why we have some idle time, 2 minutes in here. So this idle task means that just let P1 wait for next job. Right? Does it make sense? Okay, thank you. So yeah, so idle task can be between the two tasks if there are no ready job, right? So ready is already weird. So okay, so let's see what I mean. Okay, so here, so time, so 0 minute at the starting point. So we know that T1, T3,
Going back to school.
T4 are ready, right?
How old is she? She's 15. But when you were going, so this dude, she had her ex-boyfriend. And this ex-boyfriend. That lives like literally like right down the street. Like 2 like.
Yeah, sometimes it happens. Okay. Okay, sorry. Okay, let's get back to the class again. So from this chat. Okay, so in the starting point, T1 and T3 and T4 are ready. And at this starting point, according to the priority list, T4 is the most important one, and T1 is the second important one, right? So we just assign T1 and T4 on the processor. And after 3 minutes done, so after 3 minutes, then T1 is already completed. And processor 1 is working on T4 and still needs 6 minutes to complete the T4. And now only possible processor which can do some task is P2. So, and also we have T3 is ready, right? At this point, and no other tasks are ready because yeah, T3 is not completed at this point, so T2 is not ready. So that's why we assign T3 on P2. And after 6 minutes more, so at this point, 9 minutes are flowed. So we know that T1 and T4 are completed. So T4 is more important. It means that just given priority list. So if your priority list is changed, then you're definitely the order of tasks will be changed from this algorithm, right? So this priority is just given. And so after 9 minutes, T1 and T4 are completed, but still P2 working on T3, right? On T3. So only processor which can do some task is P1, but no other tasks are ready, right? Because T3 is still working on, so it is not completed, and T2 can be done only when T1 and T3 are completed, right? So at this point, no other tasks are ready, so P1 should wait until the T2 is ready, right? So that's why we said that just P1 gives some idle time at this point. And after 11 minutes total, or after 2 minutes more from 9 minutes, then in that T3, now T1, T2, T3, and T4 are completed, right? So, and P1 and P2 both are available. And we know that T2 is ready at this point because T1 and T3 are completed. So that's why we assign T2 on P1 because P1 is the lowest number processor to complete it. And there are no other tasks which can be completed. So P2 is still idle. So, and after how many times T2 take? After 7 minutes more. Yeah, so after 18 minutes, all tasks are completed. So jobs are done, right? Does it make more sense? Great. Yes, in the exam, actually we will deal with such an example that I will give you some kind of recipes or some kind of situation, and you need to turn it into a diagram, and you need to also turn it into a scheduling. So that will be on the exam. Yeah. So again, so priorities can be changed, right? So this is not fixed one. So it may be changed, then your scheduling also will be changed according to these priorities. So let's see some other ones. So example 1.5 deals with the independent tasks first. So independent task is easy, right? So in this case, there are no dependent ones. So you can just do the task using the priority list. So schedule this task on one processor according to the list processing algorithm with priority list T6. That's the first most important one. And T4, T1, T2, T3, T5, right? So first one, T6 first, and it takes 3 minutes. So after 3 minutes, it's done. And then we can do T4, and it takes 4 minutes. So here is T6, this is T4, 1, 2, 3, 4, and job is done. And then next one is T1, which it takes 2 minutes. And so job is done. And next one is T2. It only takes 1 minute. So after 1 minute, job is done. And T3, it takes 5 minutes. So 1, 2, 3, 4, 5. After 5 minutes, your job is done. Then last one is T5. It takes only 2 minutes. So after 2 minutes, your job is done. So the completion time for all the tasks is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7. So it takes 17 minutes, right? Does it make sense? Okay. Got it. So in case when you have only one processor and you have only independent task, from this you can actually infer that in this case, the completion time is nothing but sum of all minutes on the task, right? So it is just sum of all time completing each task. So in this case, 2 plus 1 is 3, 3 plus 5 is 8, 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 3 is 17. So that's why we can get 17 here. But in case of using 2 processors, then first of all, say the first one is P1 and the next one is P2, then you can just assign T6 at the first processor and next one T4 as the second processor. In that case, T6 takes 3 minutes and T4 takes 4 minutes. So after 3 minutes, you can assign T1 at the next because they are independent, so you don't need to care about the dependency. So in that case, T1 takes 2 minutes. So after 2 minutes is done. So after 4 minutes, P2 just complete T4. So at this point, you can assign T2 at P2, and T2 takes 1 minute. So it's completed. Then you have the remaining jobs are T3 and T5, and T3 is important, more important than T5. So assign T3 on processor 1 and assign T5 on processor 2. Then T3 takes 5 minutes and T5 takes 2 minutes. So the remaining one is idle time for T2. So in that case, the completion time is determined by when P1 just do all the tasks in the schedule, right? And it will 10 minutes, right? So the completion time is 10 minutes in this case, right? Do you have any question? Does it make sense? Good. Okay. Great, right? So from here, maybe if you change your priority list, then maybe you can just decrease some idle times, right? So in case of every task is independent, then we have some kind of priority list which gives you the optimal one, which is called decreasing time priority. Yeah. Maybe there are some. So yeah, 10 minutes is came from T6 plus T1 plus T3 because in T4 and T2 and T5 is already completed before completing process of P1, right? So decreasing time for to list is created by listing all the tasks from the longest one to shortest completion time, right? So for example, actually it is the same example as above. So we have completion time 2, 1, 5, 4, 2, 3. Then the longest one is T3, right? Which takes 5. So our decreasing priority risk just start with T3. And the next longest one is T4. So it is decreasing time priority risk. So T3 is the longest one, which takes 5 minutes. T4 is the next longest one, which takes 4 minutes. And T6 is the next one, takes 3 minutes. Pardon? Oh, T1 takes 2 minutes, right? Yeah, so after T6, yeah, you need to take T1. Yeah, because T6 takes 3 minutes, right? Great. And as you can see, actually T1 and T5 has the same completion time, right? So in that case, if in case of a tie, the lowest number task is done first, right? So because T1 and T5 has the same completion time, just let T1 do first, and next to T5 also takes 2 minutes. And the last one is T2, which takes 1 minute, right? And using this decreasing time priority list, you can also schedule your jobs using list processing algorithm. So first of all, in this case, T3 takes 5 minutes. So you can just write T3, assign T3 on P1 and T4 on P2. Then after 4 minutes, T4 is done. So you can assign T6 on P2. And after 5 minutes, P1 just complete the T3. So you can assign T1 in here. And after 2 minutes, yeah, T1 and T6 are done. Then the remaining one is T5 and T2. So assign T5 on P1 and assign T2 on P2. Then there are only 1 minute of idle time for P2. Then done, right? Then it takes 1, 2, 3, 4, 5, 6, 7, 8, 9 minutes, right? So 9 minutes are needed to complete all the tasks, right? And from comparing, okay, do you have a question? Which row has the idle time is matter for what? Yeah, it doesn't matter, yes. But usually in case of this list processing algorithm, the last row will have the idle time because, first processor is always considered as a priority processor. So we just assign your job on the first processor and second processor first. So usually the last one has some idle time. Yeah, that's a good question. The question is that doesn't matter so which processor has idle times, and the answer is that usually the last processor has some idle time because all jobs are assigned for first processor first and second processor second and so on, right? Does it make sense, Alexander? Thank you. Okay, great. So in this case, if you compare those two cases, when we just use some priority risk T6 to T5, and when we use decreasing time priority risk, we can actually, save 1 minute to complete all the tasks, right? So using this decreasing time priority risk, in case of independent jobs, you can actually get some optimal schedule times. So we will run what the optimal schedule time is. So on optimal schedule is a schedule assigning processors to tasks in such a way that it results the shortest possible finishing time. So optimal schedule is just some schedule which gives you the shortest possible finishing times. And there are two cases. How can we make what the optimal schedule gives you the shortest possible finishing times. So first case is when your job is all about the independent task, right? So for example, that's the case 1. So if your jobs are all independent tasks, then your optimal scheduling time is just the largest one between these two numbers. So one of the largest ones. So one is total time over number of processors. Or the longest individual process. Right. So one of the largest one gives you the optimal schedule for optimal time for completing all the tasks. So in that case, in mathematics, we use the max as a function. So max function means that just take the larger one between these two numbers, right? Take a larger number. Okay, so let's see some examples. So for example, if your job T1 takes 7 minutes, and if your job T2 and T3 only takes 1 minute, right? T2 takes 1 minute and T3 takes 1 minute. Then if you have two processors, P1 and P2, then in any priority case, at least one processor should work at least 7 minutes to complete the T1, right? So for example, just assign T1 in the first processor. Then your processor 2 just finish all other two jobs, T2 and T3, at the 2 minutes, but still the processor 2 waits to until the P1 complete the task, right? So in that case, whole processor takes time 7 minutes, right? Which is the longest one, right? So in any of the priority list, if you just make priorities in any priority list doesn't matter, right? In this case, so in this kind of case, the optimal schedule is dependent on the longest schedule, longest completing times task. And so in this case, again, if you just calculate this total time divided by number of processor, then total time is T7 plus 1 plus 1, which is 9, and number of processor is 2. So 9 over 2, which is 4.5, is this number, and this 4.5 is less than 7, right? So that's why we need to take 7 as the time which can be done all the tasks using optimal schedule, right? And next example is this kind of example. So maybe T1 has T1 has 1 minute, and T2 has 2 minutes. T3 has T3 has 2 minutes, and so in that case, if you have 3 processors, for example, P1, P2, P3, then the minimal time can be done by just assigning each processor to do each job to complete the time in the optimal one, right? So for example, you can assign T1 in the first, and T2 in the second, T3 in the third processor, and only 1 minute of idle time in here. But after 2 minutes, you can actually do all the jobs, right? So in this case, the longest individual process is 2, and the total time over the number of processor is total time is 1 plus 1, 2 plus 2, which is 5, over the process 3 is 5 over 3. So it is something 1.66 something. So definitely 2 is greater than 1.66 something. So in that case, 2 minutes is the time you need to complete all the jobs using the optimized schedule, right? Does it make sense? So it is the case 1 when all jobs are independent tasks. And case 2 is when you have some jobs with tasks are some dependent one, right? In that case, the optimal scheduling time is nothing but time to task complete the critical path. And that's why we run critical path in the last chapter. So yeah, so what Gunnar asked is that we do both of the program and pick whichever the has a higher number, yes. So in case of the job consisting all independent tasks, right? So first of all, what you need to figure out is that whether your jobs are all independent tasks or it is dependent one. So in case of independent one, just calculate the longest individual process and the total time over the number of processors and take the biggest one. But if your jobs are not independent, or if you have jobs some dependency, then optimal scheduling time is always the length of the critical path, right? Does it make sense? Okay, then let's deal with the above example again. So here in this example, we have these are the times for completing each task. So the total time is just sum of all the time. So it is 2 plus 1 plus 5 plus 4 plus 2 plus 3, right? And in that case, it is 17 minutes, as we just calculated when we use only one processor. And number of processor in here is 2. So the one number is 17 over 2, which is 8.5. And the other number is just the longest one individual task, which will be done using this one. So in that case, the longest job is 5. Yeah. So here, the optimal scheduling time is 8.5. But 8.5 cannot be done because we cannot divide the task into the one, right? So that's instead of why we get 9 minutes as your answer, right? Mm-hmm. So in that case, 9 minutes is the answer because it is case 1 and number of total time over number of processor is 8.5, which is almost 9 minutes. And it is greater than the longest individual job, which is 5 minutes, right? So that's the, yes, you need to go into round up, not round down in this case, because it takes always the integer time, right? So in that case, if you, for example, if you got the 3.5 minutes or 3.3 minutes, then always round up to get 4 minutes. That's the possible one. Okay. Good question. So always round up when you have some, decimals, right? Decimal points. Great. And next example, do you have any other question on this example? Okay, good. Great. And next example is, what is the minimum number of time to complete 12 independent tasks on 4 processors when the sum of all the times of the 12 tasks is 60 minutes and each task requires less than 10 minutes, right? So here it is still case 1, and number of total time, well, just total time is 60 minutes, and number of processor is 4. So 60 over 4 is 15, right? And the longest individual job should less than 10 minutes, right? So we don't know what the longest individual job, but the longest individual job, say X, the time for completing longest individual job should be less than 10, right? But in this case, definitely 15 is greater than 10, right? So 15 is greater than X, whatever it is, right? So here, 15 is greater than 10, which is greater than X. So the optimal time, optimal schedule, sorry. Takes 15 minutes to complete the job, complete all the job. Okay. Does it make sense? Okay. Do you have any question on this example? Okay, great. So next one, schedule these 16 different schedules into 3 sessions, and I will leave it as an exercise, and I will give you answer for next time. So I will just write down on the lecture notes so that you can access it. But yeah, so let's deal with some non-independent tasks today. So in this case, it is case 2. So now tasks are non-independent. And in that case, what we need to figure out is the complete, critical path, right? So let's deal with first program. So what is the completion time for the job shown in the diagram using only one processor, right? And our priority list is T3 first, and T2, T1, T4, T5, right? So here, since T3 is the top on our priority list, so just start with T3, and it takes 7 minutes. So 1, 2, 3, 4, 5, 6, 7. So at the 7 minute, it was done. And next priority list is T2, but T2 cannot be done because T2 is not ready, right? Because T1 and T3 are needed to be completed to making T2 ready. So instead of T2, we need to finish the next one, next priority one, which is T1, right? And T1 is ready at this point. So we can just do T1, and it takes only 3 minutes. So after 10 minutes from the initial time, T3 and T1 are done. Then now what we have is T3 is done, T1 is done. So T2 and T4 and T5 are left. And T2 is now ready, right? Because T1 and T3 are completed. So you can do T2 first. And it takes 8 minutes. 4. So after 8 minutes, T2 was done. The left is T4 and T5. So, and T4 is top priority. So now to T4, it takes 4 minutes. And after T4, the remaining one is T5, and it takes 7 minutes. 19 minutes. Okay. Pardon? Oh, thank you. 8, not 12. Yeah, 22. Great, thank you very much. And it should be 29. So the completion time for the jobs using only single processor is 29 minutes, right? So in case of single processor, as you can see, this 29 minutes is nothing but just total time, right? So in case of single processor, even if the task is non-independent, yeah, it still takes total time of the, completing the job. Does it make sense, or do you have any question? Good. Then let's do it to make a scheduling for 2 processors. So in this case, again, yeah, we have the same priority list as above. So that's P1 for first line and P2 for second one. Then T3 has the top priority, so start with T3 because T3 is ready at this point. So it takes 7 minutes. And next one, we want to do T2, but T2 is not ready, right? Because T1 is not even started. So just remain T2. And then the next one is T1, and T1 is ready. So do T1 for processor 2. Then T3 takes 7 minutes, and T1 takes 3 minutes. So after 3 minutes, T1 was done. Then the remaining one is T2, but T2 cannot be done because T3 is not completed yet. So T2 is not ready. And now the remaining one is T4. And T4 can be done, cannot be done because T3 is not ready. And also T5 is cannot be done because T4 and T2 are not ready, right? So after 3 minutes, there are no tasks which are ready, right? So at this point, your processor P2 should be in idle, right? So it should be some idle time here. Because every jobs, including T2, T4, and T5 are ready at the after 3 minutes, right? Because T3 was not completed. Yeah. Does it make sense? Then after 7 minutes, whether T1 completed T3, at this point, T1 is completed and T3 is completed. Now T2 and T4 are ready. So just assign T2 on the processor 1 because T2 is higher priority than T4. And T4, assign T4 to P2. Then T2 takes 8 minutes. So here 8 plus 7 is 15. And T4 takes 4 minutes. And here 7 plus 4 is 11. And again, here after 11 minutes, so the only remaining task is T5. However, T5 are not ready until T2 was T2 is completed, right? But still T2 is still working on, not completed. So at this point, you also have this idle time, right? Then after 15 minutes, where T1, T2, T3, T4 are all done, then you can start T5. Now T5 is ready, and you can assign T5 on P1, and it takes 7 minutes to complete it. So it's 22, and still your processor 2 has idle time, right? Okay. Do you have any question? First of all, for the question is that do we already have some priorities? And the answer is it depends on the problem. But usually, some program asks you about the decreasing time priority. So in that case, yeah, and that program asks you to make a priority list. But otherwise, a lot of programs actually give you some priority list and use that priority list to complete the schedule. Yeah. Okay. Do you have any other question? Okay, so usually in the non-independent tasks, then they will give you some priority list. Then you can just do scheduling using that priority list. Okay. So in this case, the next question is, ask the schedules in A and B are optimal, why or why not? So just thinking about whether the schedule is optimal or not. So here, it is non-independent task. So here, from this, we know that actually the optimal time is depends on the critical path, right? But here, critical path is this, right? T3, T2, T5, because 7 is the most biggest one number, and 8 is most biggest number comparing with T4, and T3, 7 is also biggest number comparing with T1, right? So if you just add all the times, then 7, 8, 7 gives you 15 plus 7, which is 22, right? So length of your critical path is 22. Right? So in the first case, we took 29 minutes, right? But however, in the second case, we only take 22 minutes, right? So it means that since the length of critical path 22 minutes, so B is optimal, right? Because A takes 29 minutes, which is greater than 22, but B takes 22 minutes, which is just the length of critical path, right? Does it make sense? Okay, do you have any other question? Great. So let's do it next one, which is making a fighter. So yeah, actually these are what we did for the last time, but you can turn your fighter recipe into diagram. And yeah, one of this kind of program will be given in the exam. So first of all, let's check how we turn this task into a diagram. So First of all, what we need to do is just rice, chicken, and onion, which takes 5 minutes. So it is just task 1 because it is done first. And oh, okay. I think that just T1 is just considered as one job. And next one is just cook chicken in 10 minutes. And add onion with chicken, it takes 5 minutes. And add seasoning in 1 minute. And chop tomatoes. But chop tomato is, chopping is actually independent job among this, cooking the chicken, right? So that's why we have T5 as the starting point. And mix with cilantro. So cilantro is mixed with these tomatoes. So T6 mixing with cilantro depends on the chopping tomato. And warm tortilla is also another job because tortilla is just another material. And serve it means that just you need to mix everything to serve it at once. So the last one is just require all other previous jobs, right? So that's why we have such a diagram. And from this diagram, you can use the least processing algorithm to using 1 and 2 processor to make fajitas. So first priority risk given is this. So first one, we want to do T6. Yeah. So Dawson asked me that why is the onion and chicken in T1 not separate? And I think that this is my mistake, sorry. Yeah, so I think that, so just assume that T1 has 5 minutes, sorry. Okay, thank you for pointing out. So in this case, we want to start T6 first. So, but T6 is depends on T5, right? So in the starting point, only T1 and T5 and T7 are ready, right? So in this case, what you can do is only among those T1, T5, T7, right? And T1, T5, T7 are ready at starting point. And here, using this priority list, the most top priority one is T5, right? Because T5 is in the second, and T1 is in the next, and T7 in the last. So in that case, do T5 first. Yeah. And T5 takes 4 minutes. Then after 4 minutes, now T5 is just done, and the ready task is T1, T6, T7 ready at after 4 minutes. So here, and T1 is the most priority one. So T1, just do T1 first, and it takes 5 minutes. And again, now T1 was done. Then, okay, so here, the remaining, the ready job is T2, tasks which are ready at the point after 9 minutes is T2 and T6 and T7, which are ready after 9 minutes. So here, T6 is the most priority job because it is on the top. So just take T6 at this point, and it takes 2 minutes. So T6 was done. Okay, so T5, T1, T6 was done. And then still T8 needed to complete other T4 and T7, but T7 was not completed, so T8 is not ready. But so at this point, T2 and T7 are ready after 11 minutes, right? So, and T2 is much more higher priority, so take T2, and it takes 10 minutes, 4, 5, 6, 7, 8, 9, 10. So 21 minutes. And T2 was done. And after T2 was done, you can do T3 and T7, right? Those are already after 21 minutes. And again, from the priority list, T3 is the most higher priority than T7. So you can do T3, which takes 5 minutes. 26. Then after doing T3, T4 is ready and T7 is ready. So in that case, T4 has higher priority. So take T4 and it takes only 1 minute. Ready after 22 minutes. And after finishing T4, only T7 is ready, right? Ready. Because T8 is not ready until every other jobs are done. So after 27 minutes, 26 minutes, sorry. So T7, which also takes 1 minute. And the last one is T8, right? Because all other jobs are done. So 28, 29. So it takes 29 minutes to complete the job. Okay. So T6 for T1, what do you mean? Mm-hmm. It would still be right if we did T5, T6, T1, correct? Because T6 only needs T5 to be done, and it's higher priority than T1. Yes, so yeah, because in that case, T6 is needed, yeah. Yeah, T6 should be first, right? But T6 cannot be done until T5 was done, right? Ah, you're right. Sorry. Yeah. So what her question is that actually why T6 was, right? T6 should be done first before T1. And I think that her right because we already do T5, so T6 are ready at this point. So I had a wrong in here. Thank you very much. Yes. So here T6 should be done. And here, yeah. T1 should be done next. So it should be T6, which takes 2 minutes. And yeah, 6 and T1 at this point will be done, which takes 5 minutes. Okay. And from the question, oh, Rainy, okay. So yeah, so T1 will be chosen at after 6 minutes. Yeah, and after 11 minutes, we need to take T2. Yeah, and so I think the other ones are okay. Yeah. Okay, great. Thank you very much. Mm-hmm. Do you have any other question? Good. Okay, so that's the case of one processor. And in case of two processors, yeah. So again, priority list is the same. So at the first point, T1 and T5 and T7 are ready. So, and T5 is the top one. So we can just T5 first, and we can do T1 next because T1 is the third one in the priority list. And T5 takes 4 minutes, and T1 takes 5 minutes. So 4 minutes, and T1 takes 5 minutes. So after 4 minutes, you can do the next priority one. In this case, T5 was done, so we can do T6, right? So here, we just, because T6 is the top priority in the list, so T6, which takes 2 minutes and 6 minutes. And after T1 was done, then what you can do is T7 or T2, but here T2 has greater priority than T7, so we can do T2 at this point, and T2 takes 5 minutes. 1, 2, 3, 4, 5. So it was end at the 10 minutes. And after doing T6, what you can do is T7 or T2, but T2 was done for, T2 was still completing for P2. So all you can do is T7 at this point, right? So here you have some idle point. In T2 takes 10, thank you, yeah, great. So 2, 3, 4, 5, thank you very much. So I'm not good at counting, so, okay. So P1 should have some idle time at this point because, because we need to wait until all other jobs are done. Because yeah, at this point, after completing T7, there are no no job which are ready. So thank you, Madeline. Okay, and after 15 minutes, then what you done is T1, T5, and T2, and T6, and T7. So all you can do is just T3. So just do T3, which takes 5 minutes. And at this point, your idle time will be done for processor 2. And after finishing T3, you can do T4, right? So, and you can do T8 because they are also in the single line. So in that case, 15 minutes, 20, 21, 22. So it takes 22 minutes, right? And lastly, we know that in this graph, critical path is this one because it is much more longer. And it takes 22 minutes if you add all the times, and the length of critical path is 22 minutes. So 3 processor cannot make the meal preparation any faster because critical path is 22 minutes, which is just, already done by 2 processors. Yeah, sorry for taking much more time. So let's call it a day. And if you have any question, please let me know. Oh, yeah, processor 2 cannot do T4 or T8 because, T4 is dependent on T3 and T8 is dependent on T4. So until the T3 was done, you cannot do T4, right? But T3 still is working on, so that's why we have some idle time. Yeah, I've got your email, so yeah. Are you back? So are you everything goes? Okay. So first of all, you can see the recorded lecture in the eCampus. And I think that in between those you're absent, there are no quizzes. Only quiz too for video. So did you take video? No? Okay, then could you take your video quiz for some questions in the middle. So you can see, yeah, in the eCampus or emails, right? No, I didn't penalize anything because your job is from the government. So definitely, yeah, I didn't penalize that for late absence.
You said the last week's videos, classes are online?
Yeah, online, yes. So every classes are actually recorded in the online, so you can see it.
Is there a midterm coming up?
Midterm will be done in next week. So I think that if you are missing on next week, then we will take a makeup exam. Yeah.
Just in case, because
Yeah, please let me know. But yeah, so that I can prepare. No problem. Yeah, no problem. Yeah.
a week out and
Mhm. Yeah, I understand.
but thank you.
Thank you very much. Yeah.
For being a
Mhm. Okay, so just take a video quiz and please send it to me in the email, right?
These slides and papers are online, correct?
Yes, you can see in the link on the campus, and you can see always the completed material on the regional.
Yeah, yes.
Great. Great. Thank you, Dr. Question?
Question.
Mm.
I'm kind of like confused with the critical path stuff.
Okay.
So I know the critical path is gonna be like the longest path.
Mhm.
So would it just be like that, or do you have to incorporate this one? And then why wouldn't you have to incorporate that one?
So in case there are three possible, no, four possible phases.
Okay.
So one is here,
Yes.
the other is here, and the other is here, and here.
Got it. Okay.
So in the first case, what you have is
It's like 23.
23, yeah. And the second
30.
pass, 30. And third pass, 31. And fourth pass is 35. So that's why is it 35? Is it 25?
25. It'd be the 30.
Yeah. So yeah, it should be the 31. Yes.
Okay. And then so it says the earliest time for completion of all the tasks. Is that just adding that?
Yeah. So it is just nothing but
So it's
critical
the same
pass.
length of the critical path.
Yes, you're right.
Okay. Thank you.
No problem. Do you have any other question in the Zoom?
Yes, I have a question. Can you hear me?
Yeah, I can hear you. Yes. So.
Okay,
what is your
awesome.
question?
What's like would the three processors make the meal preparation any faster for the last part?
I'm so sorry, but could you speak a little bit more louder? Sorry.
The three processors, like that last question.
The last question is that what her say is that there are some kind of cases. I think that maybe it is from the website that the last question is about some other cases.
Oh, I meant like the last question on the notes. It says
On the notes.
the three processors make the meal preparation any faster.
Okay. Yeah.
Sorry.
No problem. Yeah. So it doesn't make any preparation any faster because the length of the critical path takes 22 minutes, right? But it is actually done by this processor 2Ks, right?
Mm-hmm.
So therefore, even if you add more processors, but still this cannot be faster, right?
Oh, okay. Because they still have to wait for the other tasks before it.
Yes, you're right. So
Okay.
which was done by two processors. So regardless of number of processors, you cannot make it more faster.
Is that just for this example?
Yeah, it is just for this example.
Okay.
But in the general case, if you can achieve the time which is the same as the length of critical path, then you cannot make it much more faster, even if you have another processors. So that's why we say that this length of critical path is the optimal time for completing all the tasks.
Okay, thank you.
No problem, thank you. Okay. No, quiz is open in the Thursday to 2:45 p.m. Yeah. Yeah.
I like the window because then I can get it done early.
Yeah, so video quizzes maybe need a window, but okay, so then I will make a quiz and open in the tomorrow, is it okay? Mhm. Okay. Mhm. Mhm. Usually includes material on the Tuesday. Yeah, yeah. So okay, got it. Mhm. Mhm. Yeah. Yeah, so in this week, I actually so already busy to preparing your exams. So, but next week, yeah, I will try to give you some kind of open windows from Tuesday to Thursday. Mhm. Mhm. I think Thursday is just lecture, but I will give you some review material on the website, and also if some of you want, then I will give you some review session on this, in the weekend. So yeah. Mhm. Mhm. Yes, just practicing question on board exam. Yes.